talk about a trapezoid. So first off, don't say anything out loud. We're thinking about trapezoids. So first off, how could you describe a trapezoid? Everybody got kind of a definition in the back of your mind? Obviously, it's a quadrilateral, right? And then we would say what?
Two slanted sides.
What?
Two slanted sides.
Not necessarily.
One set
Two
parallel lines.
One set of parallel sides. The only reason I didn't say what, not necessarily the Jackson, is this, right? Normally, yes, Jackson, we're thinking this, right? That being a trapezoid. But remember, this also could be a trapezoid. And then realistically, that side's not slanted. Okay, so that's still. So, Cam's, when he says that we have one set of parallel sides, that was actually true. Okay? Did we know anything else about a trapezoid? What happens? What about consecutive angles again?
180.
180 degrees are supplementary, right? Not a big thing in this though, okay? So if you think about this in a sense, we're again trying to figure out the area, right? So what do you think we need in order to have an area? What did we need yesterday in order to find the area? We needed a base and a height, right? So again, the height was found by looking for that what? The right angle, the box. Okay, so in the top one, do I have a height? Not necessarily right now, right? So my height, a lot of the times in the trapezoid, is going to be that dashed line that we showed yesterday. Either coming from a vertex, or even right down the middle, or you could realistically say that you could draw this, and that would be your height out there. Okay? But we still need a height, right? But in our case, with a trapezoid, how many bases do I really have?
Two.
I really have two, right? No matter if we're looking at the one on top that Jax was thinking about or the one on the bottom that I said, right? So we have to have a combination of those two bases, right? So my area for a trapezoid, again, make sure that it's capital A, because capital A is going to be different than little a that we're going to talk about Monday, okay? Is equal to base times height, but how many bases do I have?
Two.
So, I gotta have both of my bases. Well, what do you think we're gonna do with the two bases? We're gonna add them together and divide by 2. So basically, we're taking the average of the bases times, bless you, the height. So there's multiple different ways of writing this, honestly, right? Sometimes people write it as 1/2. B1 plus B2 times H. Those are the same thing, right? Okay? And it doesn't really matter when you divide. Okay? Remember, when I write this, I'm still dividing by 2 or multiplying by 1/2. Okay? So, you just got to find that height again where they give you that box. All right? Questions there? So that's basically all they really talk about as in a trapezoid. So my next shape is a rhombus. And then we're also going to talk about a kite today. So, what's a rhombus?
Four sides.
Yes, it is a quadrilateral, you're right. But what's special about a rhombus? Four equal sides, right? So remember when we drew a rhombus, it was kind of like a what?
Square.
It was kind of like, oh, that was
Diamond.
it's kind of like a diamond, right?
Down.
Well, that's really bad too. That was like a kite. So what did I do with my square?
Stretched it.
Stretched it, right? Why can't I draw this today?
I'm not sure.
Okay.
Straw inside
That's
the
all right.
squirrel.
Kind of, I don't know if it's true, but. Okay, so here's again now the thing. It's quadrilateral with 4 congruent sides. Okay, so now what else? Don't say it out loud, let everybody think for a second. There's special things about the diagonals. So again, everybody understand what the diagonals are? The diagonals are these two lines right here. So the first question is, are the diagonals congruent?
No.
No, because if it's truly a square that's kind of pushed out on one side, right? When I push on these two corners elongate kind of, so it gets farther and farther apart. So what happens to the diagonals of it? They bisect each other. And what else? They're perpendicular. So they got to have that box, right? So if I realistically looked at this, would you say that every single time that I drew one of these, it would work out that this triangle right here ends up being the same thing as this triangle?
Yeah.
And this triangle? And this triangle? Gabriel says no. Why not, Gabriel? Remember one of the ways of showing that triangles were congruent was side, side, side? Remember that? Okay, so realistically, if I come back and instead of my outside ones, I draw 3 segments, because I really don't know if like this was congruent to that, so I really needed them to be different. But notice, like this triangle right here, I have a 3, 2, 1 side, and then over here I have 3, 2, 1, and over here and over here. So all of those triangles on the inside are actually the exact same triangles. Everybody okay with that? So what happens in the middle here? Well, what happens in the middle here is that I actually drew my box because he said that they were perpendicular, right? So besides my triangles being the same, I also know that they're all right triangles, right? So if they're right triangles, we may be able to use Pythagorean theorem, we may be able to use trigonometry, we may be able to use special right triangles like we talked about yesterday. Okay? So this leads us to, let's draw this shape first, because these two get tied together. So what's a kite?
What's a kite?
Okay, but we're going old school kites, right? Old school kites, because now anything basically gets turned into a kite. So what was the definition of a kite? It was a quadrilateral with what?
2 sets of
Congruent
congruent
lines.
segments. Size.
Congruent segments.
You need one more word in there.
Symmetrical.
2 sets of
There's the angle in between.
blank congruent sides. Begins with the C also.
Consecutive.
Consecutive, right? So they had to be back to back, remember? So when we say back to back, these 2 sides right here were congruent, and then these 2 sides right here were congruent. Remember that?
The angle's congruent.
And then what angles were congruent?
Between.
Okay, the top and the bottom in this case, or the left and the right?
Right.
It's always the ones that were in between, right? So this was congruent to that. And then when we drew our diagonals, what happened with our diagonals again?
Perpendicular.
They're perpendicular still. That's why I said they're kind of like this over here. So realistically, would you say that we had these 2 triangles would be the same again?
Yes.
And how about these 2 triangles?
Yes.
Okay, so we could still use some version of Pythagorean theorem again, maybe trigonometry again, or special right triangles, right? Because it's a right triangle. Okay, obviously the top 2 and the bottom 2 aren't the same thing. Okay, but why we show these 2 together is we're going to talk about the diagonals. So the area here for both of these, the rhombus and the kite, are going to be revolve around those diagonals. So we're going to differentiate the diagonals. We're going to show diagonals as lowercase d. But we're going to differentiate them by saying d sub 1 and d sub 2. Again, those are just subscripts, right? So we're just showing the difference between the 2. Okay? So d sub 1, d sub 2, and then you're going to divide by 2. So you're going to multiply the 2 diagonals together, and then you're going to divide by 2. Or we could say, what is 1/2 d1 d2? Okay?
Can you scale with D1?
So again, if you don't like this right here, then you could just say 1/2 d1 d2. Ladies and gentlemen, I'm telling you straight up right now, you will have to do this for both the quizzes and the tests to write down all those formulas. Okay, so on the test, the first 15 questions are all about formulas. I think so.
Points or questions?
15 consecutive questions are all about formulas.
Well, we've only done like 2. How
Four.
many more? 3, 4.
What's the test?
any problems? We did 4 equations, we're still.
How do you figure 4?
We
Well,
have.
we did triangle and parallelogram, then we did trapezoid and rhombus and kite. So
That's only 4 formulas.
4 out of 15, bro.
I don't know, maybe I
We
lied.
have a lot.
There's a lot.
Definitely a lot.
But we still got circles. We still got a couple things in circles to talk about. We still got polygons, and we still got a couple others. There's probably 10. Okay? And that's what you have to do. So again, remember when everybody says, well, I can't study for math? They're studying right there. Okay? Knowing your equations. Okay? Alright, so questions here. What the formulas? Alright, now we're up here.
Don't compare the 18 on maybe those.
Yeah, this is both sections.
Alright.
Alright, so we go back to the first section now. Again, concentrate here. Here's my first problem. So again, as we're going through this, I want you all to start thinking about it every single time. Hey, what's the formula I would use? Don't say anything out loud. Right here, what's my formula for a parallelogram? Everybody should start thinking about that. Okay? And again, the most important part of this is the kind of letter you use. Meaning capital letter versus lowercase letter. Okay? So, first things first. Notice the question. The question has 2 questions, really, right? So you better have at least 2 answers. Right? Everybody understand what we mean by the perimeter? And we can find the perimeter always because why? Well, yeah, but in a parallelogram we can always find it because my opposite sides are what again? Congruent. So why the heck did they give me 12 inches?
Oh my God.
Because I need the what? I gotta have the height. Right? I need a height.
Is that the height?
No, it's not the height, but I need a height. Right? So I need to find the dashed line.
Oh, I see.
Okay? So if they give me the 12, then I'm going to use the 12 and what else in what formula?
20 in Pythagorean.
In Pythagorean theorem because it's a right triangle, right? So anybody know what's 400 minus 144?
Pieces on it.
366.
400 minus 144.
256.
Yeah.
What's the square root of 256?
13. 14. 16.
No.
16. So 16 is my what? Concentrate. 16 is my height. So here's the question. This is important now. Don't say anything out loud. What is my base and what is my height for my formula, which is base times height? Everybody got an answer? What's my base?
32.
32, right? The 2 sides that the box actually touches are my base times height. So we're going to take a 32 times what?
16.
16 is my what? What's the label for area? Inches squared. So then when I go back to perimeter, I'm going to take what and add what 4 things together?
32, 20.
Then we basically throw out the 12. But my label for perimeter is what?
Just inches.
Just inches. Okay? Make sense to everybody? Do you need to see any of the math? So obviously, you probably did these kind of things, right? A parallelogram way back in what, 7th grade? Honestly?
Probably 5th.
Maybe 5th grade, right? But now, we didn't know about the Pythagorean theorem to get this height. So that's what the new things are, right? We're just putting new things into the problems. Nothing there.
Can you stop looking at the answers?
Gabriel, are you cheating again? Alright, here's the next one. So, when they give you this problem right here, again, I need my base and my height. So, here's the problem. What is 12?
The whole thing.
The whole thing. Okay, so, how do I find H? I can either use special right triangles, or if you don't like special right triangles, then I have to go back and use what? Regular trigonometry, SOHCAHTOA, right? Okay?
How'd you
So,
do that with sort?
what?
How'd you do that with trigonometry?
If I'm going to do this with trigonometry, I'm basically asking myself, what relationship does this angle have with this side and this 9 side?
Opposite.
Opposite over what?
Hypotenuse.
So what's opposite over hypotenuse?
Sine.
Sine. So I do sine of 45 is equal to h over 9. If I'm going to do special right triangles, what do I do with 9 to get to h? Divide by the square root of 2. Okay, so it's 9 divided by the square root of 2. Now, obviously, the biggest thing that you have to convince yourself is what in this figure. It's not drawn right. Because if this is 45 degrees right here, that means this is 45 degrees, and that means this height and this length right here are actually what? The same. And there's no way, if you would look at it, that it would be the same. Okay, so you just got to convince yourself. So you need to see the math.
Sure.
Yes?
Scotty does.
So we're going to say, let me write it up here, it's easier. So we're going to say the sine, we can either do it as the sine of 45 degrees is equal to h over 9. And then when 9's on the bottom, what do we do with these two things? We just multiply them, right? That should be the h. If we do special right triangles, then we have this, right? 45 and 9. So we would have had, what? 1 square root of 2.
Yeah.
So we're going this way. So we need to take 9 and divide it by the square root of 2. Those two problems right there should give you the exact same answer. The exact same answer. Okay? So, did somebody do it?
9 squared 2.
What's 9 to
4.
6.4. Here's the other thing that I don't know if you saw it up there. Do not round until the very, very end. So is it more than that?
Yeah, 6.36.
You got to use that entire decimal when you do your area now. So again, once I find that answer, which is 6.4, whatever, I'm going to take that times what? 12. Everybody good with that? And then you can round at the very end. What'd you get? Times 12.
76.4.
76.4. Everybody else get it? Or now we're doing it? Okay. Let's see if Gabriel's right. So again, some of these slides I don't like. See how they rounded? So their answer is probably different than your answer, Gabe. But again, our answers are all going to be the same because you're not going to round until the very end. And then again, if we go back to the problem, what should our answer say as our label?
Inches squared.
Centimeters squared.
What? Centimeters squared. I don't know if that wasn't the right one.
Say that.
But in that, or whatever it is, just make sure. And again, if they don't give you a label, then we just say what? Units squared. Okay? Questions there? All right. Then we went to our triangles, right? So that, like I said, this was one of the triangles that they'll show. What am I going to use for my area? 12 and 9. Why would they give us all the other things? They would give us the other numbers if they asked us for the perimeter again, okay? If you're asked to find the perimeter again, you would not use the 9, okay? So we do 12 times 9 divided by 2 to get my area, right? Everybody all right with that? Hopefully triangles aren't real confusing for you. Same difference. Oh, I want to definitely go over one of these. The height of a triangle is 12 inches more than its base. The area of the triangle is 560 square inches. What's the base and the height? So again, I'm going to start out by writing my area formula for a triangle, right? Base times height divided by 2, or 1/2 base times height. Okay, so now you got to go back and you got to read it again. The height of the triangle is 12 inches more than the base. So basically, why I can't just use this is because I have way too many what? Variables, right? So we know what this is. We know that this is 560. But even then, we still have a B and an H. And you can't have them with two different variables. You got to make one of them into the other. So with the information that we're given, which one are we going to make what?
How you do it H plus 12?
So how are you going to write it?
B plus 12 times B.
So I'm going to turn this into B plus 12. Everybody agree with Brandon? And now that's an H. But notice we just have B's in our problem. So that's good for us. So how do I get rid of this 1/2? I'm going to multiply by 2, right? I'm going to multiply by 2 on both sides. So 560 times 2.
1,220.
And then what do I do with my B?
Distribute
I got to distribute this B through there. So I get B squared plus
12B.
12B. So if I have B squared, what should automatically jump into our minds? I either got to do the quadratic formula or I got to bring everything to one side, right? And I'm going to try to factor it. Okay? Or I do my quadratic formula. Negative B plus or minus the square root of B squared minus 4AC all over 2A. And this is what Gabriel was talking about yesterday with this AX squared part, right? This is A, this is B, and this is C. Okay? So again, totally up to you how you do it. If you like to factor, you try to factor. Now obviously 1120 is a little different, right? Okay? I don't know if you can factor it or not, honestly.
So what if you need two different equations out of it though? So just combining them into one.
How are you going to make two different equations of it?
B plus 12 equals 560, and then
But B plus 12 is not equal to 560.
Okay.
That's why you can't make two equations. Okay? So by this, I would say it's probably B, right? 40 minus 12, or 40 minus 28 is 12, but I don't know that for certain. Maybe it's D. I'm eliminating A and C, because if I subtract those two, I don't get 12. You understand what I'm saying?
Yeah.
So it could be D or B, right? Because they both equal to 12. Then you just have to check it out. But that's why I don't like multiple choice problems, because you can basically use what they give you. I can eliminate two of them right away. Kind of cheating the system, right? Okay. So is 28 times 40 1120? 2, 3,
Yes.
is 26 times 38 1120?
No.
There's my answer. My answer is B, and I didn't even have to do it, right? That's why it's,
Oh yeah, so you just
that's why multiple choice to me is
Awesome.
cheating in math. No, it's not awesome. Because you don't have to do anything. But does everybody understand this part of it? And then you just do the math. Okay? This is the important part, trying to set that up. Okay? Alright. Then we go on to today's stuff.
So gotta learn how to hold it. Wait.
No, I already learned.
So here's my trapezoid. So again, obviously, everybody okay? Somebody said it, maybe not in this class, maybe in the other class. The biggest other thing that you got to make sure of is that your labels are always the same. So notice here, 3 centimeters, 2.5 centimeters. If one of those are meters, then the first thing you got to do is convert everything into the same thing. Okay? So we're going to take this and plug it into here, right? Whichever one you like to do. Everybody okay with that? You need to see the math. This one's really easy because of 1, right?
oh that's
So the same thing right here. Now we kind of go backwards, right? Find the area of the deck. So here's a question. Can I figure this one out? Don't say anything right here. Let everybody have a chance to think. Miguel designed a deck shaped like the trapezoid shown below. Can I find the area? Can I do that?
Yeah,
Because why?
Make a triangle out of that.
yeah, out of the 5 and the 4 foot, you're gonna get,
Okay, so if I make this triangle right over here, I'm sorry, this isn't going to be straight. Okay? And I know that I have those two things. What do I need to do?
find the bottom side, subtract it from 9.
Right, I need to find this little section right here, right? Because if I eliminate this section, that's gonna give me my other what?
Oh, yes.
My other base up here, right? So basically I don't have b sub 1, right? So if we do this as 4 right here, what's this? Pythagorean triple. 3, right? 3, 4, 5 is a Pythagorean triple. So if this is 3, what's b?
6.
No, 6, right? b is 6.
Oh, yeah.
3 and 6.
Okay, so then we would use 6 and 9 as our two bases, and my height would be 4. Okay with that? And then obviously my answer is going to be feet squared. So what's 6 plus 9? 15 times. Now here, you can divide whenever you want, so I could take 4 divided by 2 and just get 2, and then I get 15 times 2, it's 30, right?
Yeah.
Okay. Everybody see what I did there? So again, it doesn't really matter when you divide or use that 1/2 portion.
So how'd you find that as 30? How'd you find that as?
Because I did this Pythagorean theorem. A squared plus 4 squared equals 5 squared.
Why'd you double?
But Kyron knows that it was a Pythagorean triple, so this is 3.
Why'd you multiply it by 2?
You took 9 minus 3.
No, then I took, when I knew that this little squiggly part was 3, I took 9 minus 3 to get my 6 up here. Okay? That makes sense now? That was a pretty good problem, though. That was fun. Right?
Sure.
Here's my kite. Find the area of the kite. So all I'm going to do is what in this case?
20 times 12 goes.
Right. So again, this is where I'm going to divide by 2 right away to the 12. So I'm going to take 6 times 7 is 42. So again, you don't have to wait to divide by 2 at the very end or multiply by that 1/2. Right? I'm just trying to make the math easier, right? So do I have what I need in this case right here to find the area of a rhombus?
Yes.
Yeah, because really all I have to do with my 7 is what?
Double.
Double it, and then with my 9 I have to double it. So I'm really taking 14 times 18 or 14 times 9, right? Again, all I'm doing is I'm deciding when I'm going to divide by that 2 or multiply by that 1/2. If that confuses you what I'm saying to you, then just do D1 times D2 and then divide by 2 all the time.
Yeah, you just take 7 times 9.
Oh, gee, 1/2 of B.
No, I can't do both of them.
You did 1/2 of B.
Right. I either have to do 1/2 of D1 or 1/2 of D2. I can't do 1/2 of both.
Okay.
So like Brandon just asked, I can't take 7 times 9. It's either 14 times 9 or 18 times 7. I can only do it once. Okay? And again, if that confuses you, you just do D1 times D2. I don't know if there's... So this is kind of the same thing here that we did with this problem right here. Okay? One diagonal of a rhombus is half as long as the other diagonal. If the area is 64, what are the lengths? So basically, with this one right here, you end up having 1/2 times d over 2 times d, and then divided by 64. So you end up with 1/4 on the bottom instead of 1/2. Okay? Again, hopefully that's just kind of simple math. And then don't be shocked that if you have to go in reverse order, right? A trapezoid has an area of 210 square yards. Find the height. So basically we're just working backwards now, right? So again, this is where some of you don't like to write things down, but again, I would always start out with this. 1/2 B1, B2 times my height. And then I'm just going to fill in things, right? Well, now they tell me I have my answer. So 210 is equal to 1/2 times, and then I have my 2 B's, but I'm looking for my H. So again, that helps me just so I can see what I'm actually going to do. Some of you try to do that in your head, and then you get lost sometimes. Okay? Because we know what's inside some of your heads, right? So are we good with this math? The first thing I'm going to do is multiply by 2, and then I'm going to divide by this number, this total number. Okay, so we get what, 420? is equal to 70H. So what's H? 6. 6 what now? Yards, right? So we go back to a height, and then you just have to use the number again. Or sorry, the label. Don't square it. The only time it's squared is when I'm talking about the area. Okay? Questions here? All right. So, if you want to do some problems, now you got to write down to 2, or if you want to take a picture, take a picture. That's totally fine. We'll see. Tomorrow, we might break this one into two things.
Probably two fixed terms.
Yeah, so we'll do check for understanding for just section 1 tomorrow. Question.
Just this one?
Just section 1, yep. Just this one. And then we'll do the other check for understanding for the second section on Monday.
Give us the homework for section 2 tomorrow. Section.
No, because we'll have another section tomorrow.
But,
So we're just skipping the section.
No, I'm gonna give you that homework right now too.
oh.
But that check for understanding won't be till Monday,
I didn't know you were giving us the second.
okay? And then we'll have a circles formula tomorrow too, for assignment for circles tomorrow. So this is just section 1 right here. So again, this will be check for understanding tomorrow. The second section is right here. And these problems we'll do on Monday. What? And then the circle ones we'll do on Tuesday.